Hello, it's prob stats, and welcome to 7.2. This is estimated population mean. It is almost identical to 7.1, except now we will do mean when we go to stat disk instead of population proportion. All right, make sure you got stat disk ready, and let's go. We will be doing the same thing, except now it's population mean. We will do confidence intervals, and we will be determining sample sizes, so nothing different. When you go through, your notation is the same. We have mean again, number of samples, the sample mean, margin of error, and standard deviation. Okay, again, the requirements must be met. They have to be a simple random sample, no options. So it's either or both. The conditions must be sample. It must be a normal distribution or n has to be greater than 30. This is absolutely an or. It does not have to be both. Both is nice, but not mandatory. All right, now when we go through here, the margin of error, we do have a calculation. So the margin of error is, this time it's a t because it's called your mean, so it uses t instead of the z of alpha over 2. This is your standard deviation, square root of how many you have. It uses degrees of freedom. So this is degrees of freedom is what this stands for. And all that is one less than the number of people you sampled. So nothing too exciting. Confidence interval is the same. We have a 95%, so your alpha would be 0.05 again. We calculate t of alpha of 2 is a critical value. Alpha of 2 is just like when we did our z's, and it even draws the same. Rounding, confidence no more than one more decimal place is used just like before. One more decimal place, a summary statistic intervals to the same number of decimal places. But we usually just use what stat disk gives us. A student t distribution can be found by t. This is your mean of your population minus the mean of your sample minus the population standard deviation divided by the square root of n. Again, we will be using stat disk. Degrees of freedom, again, is n minus 1. Your critical value works the same, except now it's a t of alpha of t, and we use using stat disk. Okay, student t distribution is different from different sampling sizes. So n equals 3 and n equals 12 give you different distributions. The larger it is, the closer it becomes to a normal distribution. So like n3 is your blue one here. If you see it's smaller than your n of 12. They are very close, but they are not identical, so that is a very big deal. It has a general symmetrical bell shape, just like always. It is more variability, so the smaller the sample size, so the larger the sample size, the closer they get. A student t distribution has a mean of t equals 0, just like the standard normal. The standard normal distribution has a mean of z equals 0. This is the same. The standard deviation of a student t distribution varies with the same size, but is greater than 1. All right, so like a standard normal distribution, s equals 1. This is not true of your t distribution. Sample size n gets larger, the t distribution gets closer to the standard normal distribution, which we have already talked about. So let's see what we got going on. Okay, we want to construct a confidence interview for me. All right, it works very similar to our other one. We will be using stat disk again. You have to make sure your two requirements are satisfied. It's a simple random sample, and it's a population is normally distributed, or n is greater than 30, one or the other, not both. Okay, if your standard deviation is unknown, which is usually the case, we use n minus 1 degrees of freedom to find the critical value. We evaluate the margin of error. There is a formula. We can use t of alpha over s over square root of n minus 1, or stat disk to find this for us. We're going to use the value of calculated margin of error and the sample mean to substitute the values in one of the formats for the confidence interval. So we will either do the minus this, or the plus or minus, or the parentheses. Remember, all three of those are identical. round to 1 decimal. Here we go. We want to find a critical value of t of a2, the 95% confidence interval, given that the sample size has n equals 15. All right, so we will do this on StatDisk. So make sure you got StatDisk open. So let's go there. So analysis, probability distribution. This kind is called a student t distribution. Degrees of freedom is n minus 1. And let's see if I can remember. So if we're doing our 15, so we do degrees of freedom is 14. Okay, the t-value is what we're looking for. We want to find the value to the right of the t-score. So we're going to plug in 0.025 and we're going to hit evaluate. And we get our t-value of 2.144789. So let's go back to our stats. So if you look here, we got 2.144 rounded up. Now remember, this t-value is the same on both sides actually, because it works just like our normal distribution. Nothing different other than here we are finding an interval for the mean, our mean. Okay, let's oh, I wrote this problem wrong. Construct a confidence interval for mu corresponding to 90% confidence level, and this within the mean should not be here. That is something else that's coming up. So get rid of this. Using our data from question 3 of the survey. All right, when I did this, this was not completed yet. So I made some of this stuff up. And I said we had a standard deviation of 10. And then I said we had a mean, I think I made this up. And I said that was 63. And then my confidence interval was of 90%. So my alpha was 0.10 and my alpha over 2 was 0.05. All right, so now let's go plug this into our StatDisk. So now we have analysis of student t-chart again. This time our degrees of freedom, since we had 53 people, this will be 52. The t-value we don't know. The area to the right was 90%, so this time it's 0.05, and hit evaluate. And we get a t-value of 1.674688. All right, let's go back to our Word document. So now that we found our t-value, which is kind of what I actually wanted to do here, of 0.05, this is equal to 1.674846. I cannot write today. 88. Now, if we actually want to construct our confidence interval, let's go back to our StatDisk, and it works just like before. So now, analysis, confidence interval, but this time it's a mean of one sample. Okay, confidence interval of 90%, so change that to 90. Our sample size was 0.53, so and I have 52 of them. Our mean, we made that up. Remember we said it was 63 with a standard deviation of 10. All right, and hit evaluate. So our confidence interval is 60.67680 and 65.3232. Let's go back to our thing. So our confidence interval, we had 60.6997 is less than our mean, which is less than, I don't remember for sure what this was, something like that. It could be a little off. And we've now constructed our confidence interval and found our error, our t-value. Nothing too major, right? Okay, point estimator, again, is the same. We add for the points estimator and we subtract for the margin of error if you're given both of them. Nothing different from before. The sample size must be our simple random sample. And again, we will use stat_dis to calculate this, but if you do not have that at home, it's z alpha over 2 times your standard deviation divided by your error squared. Hopefully you have your stat_dis. Dealing with an unknown alpha when finding the sample size. So if we do not know our standard deviation, you just take the range divided by 4. This does not work very well. It's only if we have to do that. All right. We will calculate the sample, standard deviation S, and use it in place of alpha. We will estimate the value of sigma by using the results of some earlier study. I said alpha, and that should have been sigma. All right, IQ test. Let's see what we know. We have a sample mean is within 3 is what we're looking for in a 95% confidence interval. So 95% confidence interval, our alpha is 0.05. We will find the z-score of 0.025, which we already know is 1.96. If you don't, you can use your stat_dis to find that. Our error here is 3. That came from our reading. And we had sigma is 15. This is previous knowledge. Remember, we did this problem earlier, and that's where that came from. So it's something we already knew. So now when we got to find our sample size, like how many we need, we use our formula here, or we can use stat_dis. So let's go to stat_dis analysis. We want to do sample size of an estimated mean. We want a 95% confidence level. Margin of error was 3 IQ points. Population standard deviation. Remember, we knew that from before. We hit enter and we hit evaluate. According to this, we will have to have a sample size of 97 people. Seems realistic. I think we could do that if we had to. All right, 97. We use stat_dis or the formula. Either one is okay. What this means, among the 1,000 statistics students, we need to obtain a simple random sample of 97 of their IQ scores. With a simple random sample of 97 students, we will be 95% confident that the sample mean is within 3 IQ points of the true mean, is what that is, which is really nice. All right, pause and try yours. Okay, cost for how many students must be randomly selected. The book could cost if we want a 90% confidence interval. Sample mean is within $10, so this is our error of the population mean. Now, remember we have to find this from our data. So I hope you went to stat_dis. All right, we went a confidence level of 90% this time. Our margin of error was 10. And our population standard deviation, we actually have to calculate that, but the one that I had from earlier was 21.3. Hit evaluate, so yours could be different than mine, and it says I need 13 people. All right, I hope you did a great job. If you have any questions, let me know. Good luck on your homework and post questions.